Hey guys, hey everyone. This is not working. No, it's working. Good evening, everyone, and welcome to our first event in Berlin by ChainSafe. Today we have two great talks. The first one is going to be by David, our CTO. The second one is going to be by Greg, our CEO. So, I'll give you the floor.
Thank you very much. I'm very excited to be here today to talk a little bit about protocol engineering, which is a topic that is very dear to my heart. Big question, what is protocol engineering? Really in this context, what we're talking about is the implementation of blockchain protocols, which in layman terms means we're building the software that ultimately runs a blockchain network. These are complex systems that involve many different domains, such as peer-to-peer networking, consensus algorithms, state storage, cryptography, and as a result, they require highly specialized teams with deep technical knowledge across many different domains. They're also typically open source, and their development is largely driven by a community initiative. And as such, it also requires a lot of non-technical competencies to implement. These implementations are generally built from a specification, which is ultimately based on prior research. And often as the team implementing, we're able to coordinate a lot of aspects of a good specification, which is a very difficult task, but also very critical to implementing something across multiple languages. As an implementer, we get a lot of first-hand insights into some of the challenges that emerging protocols also have. And as such, we're able to contribute back into the research and specification and ultimately help these things iterate. Really, the job of writing code is kind of a small portion for some. And there's also the issue of coordinated community, right? Like these are not things that are built in isolation. We don't necessarily control the direction of these things. And so there's a lot of different factors that we need to take into account. We're often charged with proposing or overseeing, reviewing different changes to the protocol, as well as addressing feedback from the community. Ultimately, as somebody who is working on one of these teams, your opinion matters a lot. And you're often given the privilege of gatekeeping certain protocol changes. As the old saying goes, with great power comes great responsibility. At ChainSafe, we've been working on protocol implementations since around 2018, and it makes up a huge part of the impact that we have in the Web3 space. We're currently working on 3 different implementations. We have Lodestar, which is an implementation of Ethereum and TypeScript. We have Gossamer, which is an implementation of Polkadot and Go, and Forest, which is an implementation of Filecoin and Rust. Each of these have different ways that they contribute to these ecosystems. And some of that is realized through the different languages that we've chosen for these. Others are by adding functionality that may not exist in other clients or solving usability issues that other teams simply haven't had the capability to do. So why do we do this? Well, it's not for any of these reasons. This work often happens behind the scenes. It's extremely tedious and complex. It leads to taking on a huge amount of responsibility, which can definitely be arduous for many developers. Additionally, these projects take a very long time. It's generally taken us 1 to 2 years to see any of these clients come into production. So it definitely is a long-term commitment. Funding varies a lot depending on the ecosystem. These are often funded through foundations who tend to be generous at times and conservative at others. There's also limited scalability of these teams due to the high knowledge requirements and specialization in certain ecosystems. These projects are also fairly difficult to commercialize as they are neutral public goods. Client diversity is often cited as one of the key drivers for multiple protocol implementations. And while I agree that it's very important, I also view it as a secondary motivation. Certainly decentralization benefits from client diversity, but simply building the same thing in multiple languages isn't getting us very far. There's very few examples to point to of this really solving many issues in blockchain networks, especially as we see more protocols move to portable state transition functions that compile to WASM or MIPS or whatever it might be. But nonetheless, having multiple teams collaborating on these things is certainly beneficial for every ecosystem and a huge plus. So why do we actually do this? I think the number one reason is the importance of public goods. Certainly this is a cornerstone of any decentralized system and really is a fundamental aspect of everything that we do in Web3. These ensure accessibility, decentralization, security, innovation, scalability, economic efficiency, and can also help to mitigate some of the issues around regulation. One of the huge value adds for us as an organization is the knowledge and insight that we gain from being a part of these infrastructure projects within these ecosystems. The capabilities we've gained have allowed us to build above and around these protocol implementations. We're given firsthand insights into some of the challenges and various technologies that different ecosystems are currently facing. As an example, this has given us a huge advantage in our contributions to Sigma, as we'd be able to take our pre-existing knowledge and focus on the interoperability problem that exists in the Web3 space. Just looking ahead a bit, I think as an organization, we need to continue to refine and maintain the value proposition of the implementations that we maintain. There are dynamic and diverse needs across different ecosystems, and it's really important that we ensure that we are actually solving those problems. The funding mechanism for some of these public goods, protocol implementations being a portion of those, definitely need to continue to be improved, and we need to continue to innovate there. We shouldn't depend on ecosystem foundations to fund these projects in the long term. There needs to be better mechanisms. Fortunately, things like Retro PGF and the Ethereum Protocol Guild are definitely beacons of hope that there are better solutions out there. And certainly as an organization, we're very eager to expand into new ecosystems to have the opportunity to be at the forefront of some of the innovation that is continuously happening within the Web3 space. Hopefully that gives you a bit of a glimpse into what protocol engineering means, what it looks like. We are currently hiring a head of protocol engineering who is a technical leader for our engineering teams. If you or anybody you know is interested, please check out our website or find me. But yeah, thank you very much for being here.
Okay.
My voice is loud. This is so funny. That's for our party on Monday. I was trying to figure that one out. I was looking around, I'm like, how are we going to dance here? This doesn't make sense. I get it. Okay. Are we good?
Yeah.
Yeah? Okay, cool. Yeah, awesome. Hey, everybody. I'm Greg. And going to kind of lead off with some stuff about David's talking about, and then kind of talk about a little bit more about Sigma and kind of what we're doing there. So, if you don't know what Sigma is, it's an interoperability protocol focused on delivering like fast, secure, reliable cross-chain communications. So the idea of like message passing, how do we get messages brokered between different blockchains that aren't deeply connected? This can be as much as go as far as to say is like, how can I make like an interaction across two chains and execute call data between them? So interact using one chain and a private key from one chain to execute an interaction on another chain, whether that's smart contract based or perhaps substrate based. That's Sigma's goal. We have multiple different ways to do it through different security thresholds and security models. A lot of that's really driven from a lot of the work on our protocol teams, like Dave was talking about. We get to a really good glimpse into like different ways and different way consensus is built and how different chains are done. And so through that, we've been able to build up some very nice and robust, so to speak, solutions on like how to get those messages across. Currently, we're live. It's live between Substrate and EVM chains, and also between EVM chains, and we're looking at a lot more after that. And yeah, what's next? Yes. And so with that, as like ChainSafe's been working with Sigma to like build up the protocol, obviously we look at like kind of what does the future and the context within Ethereum, but also generally speaking, a lot of other ecosystems, it's like a roll-up looking future or a hub and spoke model where we start to see like many chains scale out. And a common problem, the main problem that comes out of this is that we get a very fragmented system where there's a lot of sub chains where independent of their others, although they may be connected through canonical chains, other bridges. At the end of the day, when you're moving between them, and as this grows, we're going to start to see, we're already seeing the point where there's like too many options for you and your funds and your data, and that's pretty much everything about your interaction, where an app lives, where that data is, how you access an app. Might require many wallets, might mean that you don't even know where half of your funds are, you don't really know where you purchase something. And so the ecosystem will continue to fragment this way. And so at ChainSafe and Sigma, something we've been thinking about is like how we can help to try and address this today. And so we don't get a situation, we can move away from the idea that when you look at a wallet balance, you don't see Ether represented 5 different times. Ideally, we can see this as like a global piece of state. And so what's nice is more recently, this has been the topic of ours for a bit, but what's nice is more recently, the Frontier group came out with something called the K framework, kind of a way to bundle the concept of chain abstraction, so the idea of how can we abstract all these chains together, and kind of grouping topics. And this is really helpful for us to understand, where things fit in the grander scheme of things. Sigma, for example, focusing more on the settlement layer, while some other stuff we're working on that I'll get into shortly is kind of focusing more, kind of like abstracting away roughly speaking, the whole stack to a degree. And so, before I get into kind of this next bit, the way we've started to look at things internally is the idea that there's kind of like two ways. There's the way to like really think about moving forward in how we see this vast network of chains that we're using is that historically we've really thought about, you deploy your application on a single chain and that's where it lives, that's where it is indefinitely, and it's a very like single server client model. As we start to grow out, the question becomes like, can we start to fragment this a little bit further? What parts of an application state can actually be asynchronous between each other and synchronous? Because you can imagine we've been deploying up until today, with the assumption that every piece of state in an application, on-chain application, is bundled into one, let's say, contract in the EVM context. But does everything in that contract actually need to live together? Could they be more optimized by being pushed outwards to other contracts? And so if we start thinking about that way, what we end up getting to is a point where we can scale it two different ways. We can scale the protocol layer, which a lot of the protocol engineers at ChainSafe are working on. Is how do we improve the base layer scalability? Then we can also look at how can applications start to think about deploying cross networks and separating out pieces of their state that don't necessarily need to be bundled together. And by doing that, it does in fact play into the thesis that we're going to have many chains, but it also means that the communication between one application across many different state machines is going to be much more challenging. And so, we thought about, we've been working on how to do this and what a good first step is. And so that's what I want to present today with some help from this framework is that we're presenting what we're calling internally right now as Gopher. Main TBD, definitely we'll see where it goes. But for today, our little furry friend here, Gopher, is what we've been building internally. And so Gopher's key goal today is to unify assets so that you can access an app on any chain. What that really means is that Gopher is looking to basically take, say, instead of having multiple balances across many networks, we're having that kind of singular-based approach to a blockchain. We're saying use all of those blockchains as a scaled set of servers. If you were to have, let's go to a Kubernetes, or sorry, oh my god, there we go. Thank you. If you go and look at how we build apps in a microservice, you treat the tree of services underneath as still the same single application. We have to think about, if we think about blockchains that way, we can start to unify assets. What this means is that for users, when they see USDC, they see USDC, or when they see ETH, they see ETH, and that's aggregated across all the supported networks. Similarly, for a developer, what this means is you now have distribution from every blockchain network where that token is supported. And so that means that a user comes to your system. And so that's kind of the goal of Gopher. So and then what Gopher's trying to do is Gopher basically says, how can we efficiently route this in the cheapest and easiest way? This means if you have a bundle of assets, let's say 10 Ether, let's say David goes and says, hey Greg, you owe me 6 Ether from the other day. I have 10 in total, but that bundle of 10 is spread across 5 different chains. I don't want to, historically and today, the best way to do this is I have to go mainly bridge those independent balances, and probably I'm not going to care how to do it. I'm just going to find the fastest and quickest way to get it done because it's a pain. Gopher's end goal is to say, well, we need to find you the cheapest way to move that bundle of assets and treat it as a single asset from any chain. So if David said, hey, I want this on mainnet, that bundle might be cheapest to move from Optimism, Arbitrum, Base, and wherever else that might exist, so that we can get that 6 ETH back to David to wherever he wants. So what Gopher is really doing is it's removing the idea of a source chain. We go from a source chain, the idea of bridging of a source chain to a destination, to simply just saying there's a destination it needs to go to, please go there. And we do this by managing many different liquidity networks and bridges under the hood to ensure that we can actually get the cheapest quote in a reasonable amount of time. This is an example of how we're integrating it today with a DeFi protocol that's coming out shortly. In their integration, you can see the user has the option to choose where does the bundle of DAI come from in this case. They've turned on 3 of them, right? So from Ethereum, Optimism, and Arbitrum, and you can see that we facilitated 3 different ways through 3 different bridges. In some cases, this could be one bridge provider. It could be 3 completely different bridge providers. It could also be using the canonical bridges, whatever really hits the criteria that the user is looking for. And the big difference too is at the very top, the user's balance isn't what you're traditionally used to seeing, right? We're traditionally used to seeing you're on the Optimism network or ETH network with your wallet, and that's the balance that you see for your DAI. Here, we're flipping that around and saying, you have this much DAI, so you should be able to spend this much without thinking. And we're able to do this in like anywhere from like 1 to a handful of transactions, depending on what type of account you're using, if it's an EOA or a smart account. And get a cross-chain call called in all in one bundle. So really, if it's a smart account, we can get with almost pretty much one transaction, and you can go from having DAI on 3 different networks deposited directly into one contract on a single chain. And in this case, this is opening up a long position. Another example that we have for Marketplace here is that you can see there's Optimism and mainnet ETH to purchase an NFT. So yeah, you're signing the message to get it done, and there we go. Stuck in a loop. And then there you go. And so it's making 2 stops to get to Zora to purchase your NFT, but in reality, what we're doing is we're bundling from 2 different networks. And so this is really what the future of how UX should probably look like, how we're trying to solve it, and basically like the first glimpse into like what could be. As we continue to innovate, I see a big path happening on the data side as well. You know, as I talked before, the difference of separating asynchronous and synchronous state and pushing that across, and how we can try and make applications scale across blockchains rather than focusing just on deploying on a single network. And final tidbit, which is quite interesting, when we were doing some research back in the day, when we first built out the first POC, we found that Gopher also solves for a really interesting problem, which is simply just the transfer of a single asset on L1. You know, we were doing simulation tests and found that USDC was was cheaper to transfer by like a margin of, I think, 5x by using a bridge from Optimism to L1 rather than doing a transaction from L1 to L1 of USDC. And that's because the bridge that we had sourced at the time does batch transfers, meaning 10 deposits happen on Optimism, and then it moves 10 deposits on mainnet. So in one mainnet transaction, there's 10 deposits. So 10 transfers share the one single gas cost, meaning you're paying 1/10 of the mainnet transaction cost. And as a user, you would have never known that. You know, if David said, hey, I need that 6 ETH and I had that all on Ethereum, I probably just sent it across Ethereum, taking a $20 gas fee, when in reality, I could have probably gone away with like maybe 6. And so the long term, we can start to save users money by actually starting to think about how we look at interacting with many chains differently, rather than the idea of the notion that you have to move from one to the other independently. And yeah, that's it. Got some QR codes. I don't know what they do. They got added to this now. I think they probably do socials and stuff like that. Thanks for coming.
Thanks everyone for coming. We will have snacks in a bit. And thanks for showing support. Thank you.